it puts you into each of these different categories. So I know from previously looking at the data that there's a particular area around Cairns, so that's this one here. So if I click on Cairns, it will now show me the next level of the particular visualization. I know that Tully is in the ABS Region 3 Innisfail, and you can see that there's a high number of fatal accidents on the right, so I can click into here. So I'm zooming down. What I'm doing is I'm using hierarchies to zoom down through the data to then identify, oh wow, okay, so the graph on the right is actually number of fatalities, and the graph on the left is just total accidents. So I can see that although Tully has a low number of total accidents, it has a high number of fatalities, and this is just for 1 year. Let's open this up to the entire data set now and do the same thing. We're going to zoom down into our first district area, which was Cairns. We're going to now zoom down into this particular area, Innisfail and Cassowary Coast. And then we're going to zoom down into Tully, which is the top area for fatalities and crash accidents within this ABS 3 region. And now we're going to be able to see which suburbs are actually coming up as the highest number of fatalities. So Damper Creek appears to have a lot of fatal accidents, even though it's the second highest in total accidents. So this allows me to now zoom down into particular areas. If I click into Tully itself, I can even go as far as selecting an accident on the map. So this one here, and then I can double click this particular accident on the map. And I've also built an integration with Google. So this will now take me to the crash location where this fatal accident occurred, and hopefully it'll show me exactly where and what the features were on this particular crash location. So I can see this is on Bruce Highway. I've actually driven through here when I was driving through Tully last year. And I can see this is obviously a pretty big intersection. I can see there's a truck, so this tells me there's probably a lot of trucks driving. Oh, there you go. There's your Tully town welcome, which is cool. So having this ability, Tom, to drill down into the data and explore the data is how I start to pull out insights. You know, look at this. This car is turning across the main highway, even though there's a truck coming right here. So Bruce Highway is a particularly dangerous road in Queensland, and you can see it in the data. So it's really as easy as, you know, pulling in these different objects, pulling in maps, and creating actions between different objects and starting to explore the data. Does that help a little bit, guys?
They're all nodding, absolutely. They've lost their voices.
Does anyone have any questions on that?
How long did it take? How long does the programming take to get to what you've done there?
How long did this project take you and the programming behind it take to get to here?
The good thing about this platform is there is no programming. So it's all drag and drop. So you start with a blank page like this, and you've got all your data on the left and your objects. And literally it's as easy as, for instance, I mean, I can select the data here and I can do, let's have a look. Who wants to pick a variable in the data set? There's a lot of different options, so maybe get someone to choose one of them. We've got
Choose one. Crash speed. We'll go for.
Okay, so let's drag that onto the page. So I'm literally just dragging it, and you can see it says auto chart. So what the system's going to do is it's going to select an appropriate visualization type based on the data. So it's selected a bar chart as a way of visualizing that data, and I can see most of the accidents in my database are between 50 to 60 kilometers an hour. I can see there's crashes which are over 90 kilometers an hour, less than 50 kilometers an hour, so I can see this different breakdown. So let's pick another piece of data from the data set. Who else wants to go?
Yeah.
Crash nature.
Crash nature.
Alright, where is crash nature? Here. Okay, let's have a look at this. We'll drag that next to the bar chart. So we're actually building a dashboard now, guys. This is great. So crash nature. So crash nature is a really interesting variable because this is the nature of the accident. This is whether it's an angle accident, a rear end accident, whether or not the car hit an object, whether or not the car overturned. So this is a really important variable, and I can tell you from working extensively with the Monash road safety crew, which is a university group which designs all the models for road safety, angle accidents are the most dangerous, because if you think about it, if you're hitting a car on the side, on the driver's side, on an angle, there's less sort of protection on the door of the car, so there's more likelihood that that's going to be a fatal accident or lead to some kind of, particular issue. But thanks for that. The crash nature is really important, and the crash speed. But now what we can do is we can build actions or interactions between the objects. So when I click on the crash speed, it will now update and filter all of the objects on the right. So let's put automatic actions on all of these objects, and the system, when I click 50 to 60 kilometers an hour, you'll see all the different accident natures changing on the right. So now I can see that, for instance, greater than 90 kilometers, the crash nature most frequently is that they hit an object, which is interesting because between 50 and 60 kilometers, the highest frequency of crash nature is actually those angle type accidents. And then I can do things like, let's have a look at some of the locations. We can look at different suburbs or districts. So I'm going to put districts down the bottom of the page. And now we can see the frequency of accidents based on different districts. And I'm going to make this look a little bit prettier by changing from a bar chart to a heat map, only because I'm experienced and I know that tree maps visually are a lot nicer to look at than bar charts. And so because I've got all the automatic actions on, now I can select the location, which I'm actually going to drag to the top of the page because we put the most important thing at the top. I'm also going to keep the legend because it's important that people understand that size is the frequency of accidents. And then what I'm going to do is then I'm going to make this a little bit more interesting by having the size of the square as frequency and then the color of the square as number of fatalities. Okay? So now what I'm doing is I'm using colors and size to pick out interesting data narratives. So let's say I was to select North Brisbane or particular areas. Let's look at a particular area that might be interesting to us. We've got the far north. We've got, I think Cairns was the one that I was looking at before. Where are we? I can't see it in here. So let's just select Townsville. We'll click on Townsville. And then you can see all of the objects change. So I guess in answer to your question, it doesn't take a lot of time if you've got the right platform. If you were to program this from scratch, it would take a seriously long time to develop this type of capability because you'd probably need to design all the SQL queries, all of the front-end programming, so all of the HTML and CSS to create this page. But there's so many different platforms out there that make this easy for you. Tableau, Power BI, SAS has its own visualization tools, and I would sort of encourage you guys to leverage those platforms so that you don't have to build it all yourself, and you'll get a lot more insights out. So I hope that's been a bit helpful there.
Yeah, that's great.
Just on this one, just for what you've done, what are some of a simple project that students in this room can do to get into a bit of data science and just play around with some data that just from the top of your head, do you think?
So I would probably say the first thing you can do is go onto the Open Data Portal for Queensland Government and have a bit of a look around at the different data sets which are available. So that's the first thing. The second thing I'd probably encourage you to do is go on Kaggle. So Kaggle is it's sort of a data science competition website. So if you go to kaggle.com, once again, there's a whole heap of data sets because it all starts with the data, right? So identify a problem. So think about a problem. So whether it's road safety accidents, whether it's something to do with health, like spread of disease, or whatever you're interested in, whether it's environmental and you're looking at turtle movements and things like that, then go on the Open Data portal, go on Kaggle, search for particular data sets. So let's say I'm interested in movies. I'm going to select the movie, and I can see all these people have built different capabilities in data science. So this is a movie recommender system. This is a movie recommendation system, and here's a movie data set. So if I click the movie data set, you can see now I'm getting access to data. I can see it's 38.19 megabytes of data. I can see it has a whole heap of values. So the actual name of the movie, the title, the cast, who's in the crew. So I could do a whole data science project on this. And then what I'd do is I'd look for like a data visualization platform. So it could be like Tableau. I know Tableau have a free desktop version, so you can download that onto your computer. And then you can upload this CSV file of movies into Tableau and do what I just showed you. So start building some visualizations, start exploring the data set, think about ways that you might be able to add new data into it to make it a little bit more interesting. And then you're already halfway there by that stage.
And obviously, everyone here, you can anything, or Google pretty much teaches everyone everything. So if you don't know how to do something, the main part about these type of profession, once you're in the industry, you've got to find out the solution yourself. So researching how to do something, there's not going to be a teacher always over your shoulder telling you how to do it. You've kind of got to figure out a method to do this, and this is what they do in every day. So you get better at it as you go along. Very cool.
Yeah. So I just wanted to end on one last thing, because I've touched on, I've had a look at, the particular visualization, data-driven sort of, objects and things like that. But what I haven't actually touched on is the predictive side of things. And this is where it starts to get really interesting. By the way, data science isn't just about visualizing things on a dashboard. What we're trying to do is we're actually trying to build predictive models. So we're trying to take all of this data and say, can we predict fatal accidents on all of the features we've got in our data set? And so similar to what I showed before, where we can create interactions, you can see I've got a map here of all of the crashes on the left, and I can select particular regions on the map, and you'll see over here on the right, what I'm actually building is a machine learning model. So this machine learning model is a predictive model, and it's predicting fatal accidents from this historical data, and it's telling me which features in the data set are most important in predicting fatal accidents. So I can see crash speed is the most important variable in predicting fatal accidents, and I can see where most of the fatal accidents are occurring in speeds greater than 90. This particular capability is what we're actually doing as data scientists. So the first stage is building the dashboards, exploring some of the insights in the data, and then what you're doing is you're thinking about, okay, how can I build predictive models to start actually getting ahead of the game, So if it's helping Department of Transport or Department of Main Roads, change things on Bruce Highway along Tully to make it safer, if it's putting in red light cameras, whatever it is, this is what we do, and this is why we get up in the morning every day.
That's excellent. Does anyone have any questions regarding that? Mr. Tim.
Everyone else can go. We'll just...
Jonathan, sorry, my name's Darren. I came in a little bit late. When Dan said he was going to do this presentation, I thought it'd be interesting, but I did not realise it was going to be this amazing. This is incredible. So thank you for taking your time. Can I ask how many, the crash stuff that you've got, how many CSV files and databases, I guess, are you pulling information from to get all of that information? Is it from the one Queensland Government Road crash website or data set, or is it multiple that you've got in there?
Yeah, so it's multiple data sets. So I've got 1, 2, 3, 4, 5, 6 CSV files, which I've downloaded from the Open Data portal. I've got another data set which I've taken from the Bureau of Meteorology,
Yep.
And then I've also brought in data from the Australian Bureau of Statistics. So I've got about 7 or 8 different data sets.
Yeah, right.
And then I've created what I call a data plan. So there's a whole module in my platform called data preparation, where I can bring all those data sets together before I bring it into what I call the analytical base table, which is this big, massive data file which has everything in it.
Yeah, right.
It's, you know, the one-stop shop. But yeah, 7 data sets I've had to bring together to create this visualization
Yeah,
and
right.
this capability.
I guess my next question then, it leads to the accessibility. You said this is Azure, is that right?
Yeah, that's right.
And how much? What's the cost of Azure?
So this particular sandpit environment is probably about $200 a week, depending on usage. So if I use it quite heavily,
Oh
then
my
it's going to
God.
be more expensive because
just
I'm
about
obviously
fell over.
spinning up more infrastructure.
Yeah.
But if you know, I'm not using, if I use it on probably an average week, it's about $200 a week. And keeping in mind, this is for our entire team. So we've got a team of 48 data scientists and staff who are using the same platform. We're all logging in, so there's probably people logging in and doing demonstrations right now for health, you know, using the same platform. So it's quite affordable.
Yeah,
Put it
right.
this way, it's a lot cheaper than buying your own servers, that's for sure, and then having to maintain them.
Yeah, yeah. Okay. Well, I just look at the usability of this for these kids is amazing. What we could do with it. It fits our digital solutions curriculum so well. We need to work some stuff out. Thank you, that's great.
Well, we have about 2 minutes left. Does anyone have any questions for Jonathan before the bell goes? Anything that you want to say before we close this thing off? Yeah, Khan.
As like a data science, I guess as a professional, what is your like everyday kind of work day? Like, what do you actually do in a work day? Do you just like, do you usually just start on visualizations, or are you collecting data, or you know, what is an average work day?
It's a really dynamic career, so every day is very different. So I'll actually give you a look. I'll spin up my calendar. Let's have a look what my days look like. Just to give you an idea, I'm actually quite a transparent person, so let me open my calendar for you. Alright, so let's take last week for instance. Let's take Wednesday, right? So I did a webinar in the morning, a run through for a webinar. I worked on some police data for about half an hour, so I actually started working on that data. I prepared for a lab, so a data lab. I ran a webinar in the evening, so this is the one where I met Daniel on Wednesday evening. On Thursday, yeah, it's very different. So a lot of demos, a lot of meetings with, you know, executives and decision makers, and then a lot of work behind the scenes bringing all the data together. Every day is a different day, mate.
Excellent. Well, the bell's just gone. Thanks, Jonathan. I think we've got 20 data scientists in the room right now, but yeah,
21.
21. But thank you so much for that. You can go say thank you very much.